In 10 years' time, we'll need to have cut our carbon emissions by 42% and be producing half our electricity from renewable sources. Yes, I know, we've heard it all before. So for once, let's look at this another way.
Renewable energy will provide something like 50% of electricity, and by 2020 will be a significant employer across Scotland, employing something like, we reckon, 50,000 people.
Scotland has the best wind and water energy potential in Europe.
We're second to none in terms of the resource that we have. You just need to look at the energy maps of around the world. We have it all.
This is the windiest country in Europe, and it's certainly one of the wettest. But it's these conditions, these natural resources, which give us a natural advantage when it comes to generating renewable electricity. We need to harness these resources, and we need to do it quickly. Because this isn't just about the environment, it's about the economy. This is a chance to build a multi-billion-pound industry with tens of thousands of jobs. But there's one big question. Can Scotland rise to this challenge?
Scotland knows about green electricity. We've had hydropower since the 40s.
I am the sun and the air.
The next generation of renewables could produce more than 30 times as much electricity. The question is, how much money could we make from that? To answer this, we need to know how much electricity we use and how much we could produce.
Total, the potential around Scotland would be around 50 gigawatts offshore and around 10 or so gigawatts still onshore. The peak demand in Scotland would be around about 5.5 gigawatts, and that is about a tenth of what the potential is for renewable energy.
So basically, renewable energy sources could produce 10 times more electricity than we use. We could sell most of that and make money.
Build technologies, build intellectual property rights, patents and skills that we can sell on and make this not just a renewable energy supply that's there in perpetuity, but a whole new industry that's there in perpetuity.
So we could cash in here and cash in big time. Sounds like a win-win situation.
Not only is it right to move to a low carbon world, we can do fantastic things for our economy and for our people if we go in that direction.
Scotland built a worldwide industry from oil and gas, but can we do it again with wind and marine? Can we create a second energy boom? Look around you. Scotland is a windy place. Most of the time we don't even realise how windy until we try to harness it.
We have 25-mile-an-hour winds here today, which is actually a bit too strong to be learning to fly a kite, but it just shows you that even here on the beach how strong the wind can be and what a powerful resource we have in Scotland.
Wind power is what most people think of when they think of renewable energy. That's because it's the most advanced of these new technologies and is already producing electricity on a large scale. Whiteley wind farm on the outskirts of Glasgow is the biggest in Europe, producing enough electricity to power nearly 200,000 homes. The site is owned and operated by Scottish Power. Development manager Debbie Harper has been involved with the sector's rapid growth.
Oh, the growth has been vast. I think within the past 10 years we have come from about 2 operational onshore wind farms to a portfolio of about 14 operational wind farms, with more in the pipeline.
Scotland is now generating nearly 2 gigawatts of electricity from wind, enough to power more than 1 million homes.
The growth of onshore wind farms has been pretty explosive in the past few years, and half of all the electricity generated by wind in the UK is produced in Scotland. But we've a long way to go, because meeting the government targets would mean building at least another Whiteley every year for the next decade.
So has wind power made Scotland rich? Well, electricity companies are making profits and paying wages, but that's about it, because we failed to build an industry from wind. In sight of Whiteley is Myers Hill, where wind was developed in the 80s. We had a lead then, but we lost it because we didn't invest in it. Germany and Denmark did, and they're still leaders today. The turbines at Whiteley are German-built. Neil Stewart is head of the industry body for renewables.
I think if you look at what Denmark did in the 1980s, they gave a great degree of certainty to the industry. They said, if you invest, if you create a new industry, we will buy electricity that you generate. And what we need is the government in Scotland and the UK to give similar certainty to the industry here.
Peter McGregor is a renewable energy economist.
There is something of an industry here, but it's comparatively small. I mean, the main producers here are in the rest of Europe and not in Scotland. There's some activity in Scotland, but not much. It would be fair to say that there's some disappointment about the extent to which wind, and onshore wind in particular, is embedded within the Scottish economy.
Love them or loathe them, wind farms are now part of our landscape. In the past, objections have left them mired in the planning process, sometimes for years. Delays have slowed and even stopped wind development.
We've all been on a steep learning curve over the past decade. When we developed this site at first, for example, it was a challenge to everybody, developers and the consenting authorities. We've all got much more experience now in what is needed from a good site and what is achievable and what is not. The planning system is getting a bit better at dealing with that, and certainly the Scottish Government, for example, have set themselves ambitious targets for turning round applications for sites like this in the future.
Here in the Western Isles, community opposition stopped a wind farm being built on the Isle of Lewis. Even bigger than Whiteley, the proposed Bavas Moor site would have dominated this rugged landscape. Today, there are small clusters of turbines dotted around, 2 or 3 at the most. People here are embracing wind power for the same economic reasons as electricity companies, but they're doing it without spoiling this beautiful landscape.
Hi there, Neil. Hello, I'm Hayley.
Nice to meet you, Hayley.
too.
I went to Shawbost, a tiny village near Stornoway, where community organiser Neil MacLeod told me how a small wind project here was making a big difference to a community's economy.
We have a building here that is being run by a community group. The building costs money to run. We have energy that's sitting around outside us here that nobody takes advantage of. So what we've managed to do here, and others across the islands, is use the energy that's there through the natural resources of the wind.
Even a tiny project like this qualifies for the government's Renewables Obligation Certificates, or ROCs, an incentive scheme for green electricity producers. So these turbines power the building, but they also provide an income which helps keep the community hall open.
We're getting roughly about a third of the electricity that we're needing are being provided by the turbines. We generate some income from the renewable obligation certificates that are then traded on the market. So we're getting a small amount of income each year, between £800 to £1,000 a year, just from what they call ROCs. And then the savings that we're making are quite substantial in the electricity that we're producing to heat the building.
Other projects here are more ambitious. David Wake is part of a plan to bring 2 much larger wind turbines to North Harris. They're turning to renewables not because they want to save the planet, but because they want to provide a future for their families.
Kids come out of school, they go off to Glasgow, they go off to the mainland to go to college, and they don't come back. We need to build jobs, we need to build affordable housing, and it's all about building up the community, giving some strength back to it. But to do that, we need a good income stream, and we'll do that through a wind turbine or through hydroelectric schemes. The plan is to sell electric onto the grid. The money we make from that then will feed straight into the trust.
And how much are you talking about? Have you done your sums at this stage? I presume you have.
Conservatively, between 50 and 100,000 a year over a 20-year period on average.
What people here in the Western Isles are proving is that the economics of renewables can work just as well for local communities as they can for big commercial companies, because people here are using renewables to create an income stream to fund economic development, new homes, even new jobs, which wouldn't otherwise be possible. So the benefits can be just as important on a local level as they can on a Scotland-wide scale.
So people here are cashing in on renewable energy. They're producing their own electricity and they're trying to sell what they don't use. There's just one problem.
We've had to get to know the problems of the grid, understand the electric grid on the islands and how it works. Now, there's been very little investment over the years in the grid, and it's just not designed to take a lot of new renewable energy to feed back to the mainland. It's dependent on new links across the Minch, as well as refurbing, re-strengthening the network on the islands. So there are a lot of hurdles to get through before we can export the electric down to the central belt where most of the demand is.
But for now, some of these projects will have to wait and wait for a grid connection. It's a bit like waiting for a bus. I think I know how they feel. Okay, enough of this analogy. People here can't make money from renewables until they can get connected to the grid. Nicholas Gubbins is Chief Executive of the charity Community Energy Scotland. He's been helping many of the small schemes in the Western Isles, and he knows how important grid connection is.
The real difficulty and the fundamental difficulty is the ability to connect projects onto the grid system. Unfortunately, the grid system was never designed for lots of small projects scattered around the country, and it needs to be redesigned and developed to allow that to happen, which involves more connections and additional connections, taking the power back down the line.
Until this happens, people here can do little but wait to make money.
It's frustrating. It's taking far longer than I think any of us would have hoped. The grid system is really designed for last century, and we're now in a completely different context, but it's taking an awful long time to get to the point where, you know, we can now connect most of these projects on, and a number of them still don't know when the connection date's going to be. So you can imagine that with all the work that have gone into these projects and the benefits that people see coming from them, it's frustrating.
And this is a major issue. As it stands, the electricity grid just isn't up to the job. Just like a road system, the grid has a mixture of motorways with trunk and minor roads branching off. But renewable sources of electricity are far from any of these. They'll even be in the waters around Scotland, and the grid was never designed for that. There are queues of companies waiting to join the grid network. Even if they got on, they'd be caught up in the logjam. The grid could never cope with our renewables potential, which could add 5 times more electricity. It would have to be rebuilt. Jim MacDonald is one of the country's leading experts in renewables.
We're talking about rebuilding and redesigning the energy infrastructure to the same extent as we thought about back in the early part of the 20th century, when the whole idea of creating a national grid through 1926 and the Weir Act, this big vision of creating infrastructure, we need to have a similar big vision for where Scotland is going in terms of energy infrastructure, sources, and how that articulates with a European vision as well.
The grid is overseen for the UK government by the industry regulator Ofgem. I asked its senior partner Stuart Cook if he accepted that the grid was holding people back.
Of course we understand that it takes time for people to plug into the grid. We're doing everything we can, everything in our power, to speed up that process and make certain that the regulatory regime doesn't prevent it, but there are other hurdles that they need to overcome, including planning permission. We asked the transmission companies to come forward with plans that would help reinforce the grid and help ensure that all of the renewable generators could connect. They came forward and said that they had 20 projects across Great Britain. A lot of those projects are in Scotland. £5 billion worth of investment that they would like to make in order to make the grid fit for all the renewables generation that wants to connect.
But for now, grid connection remains up in the air. The new Beauly to Denny transmission line is stuck in planning limbo. This connects the north of Scotland to the central belt. The new line would have 4 times its current capacity. It's like building a 4-lane motorway right through the Highlands, where there's now only a single-track road. A decision on its future is expected any day now. Getting connected is one thing, but there's another issue close to the heart of renewable energy generators, and that's the price they pay to connect.
Sources of electricity like power stations have traditionally been pretty close to where people live, and that's made it cheaper to connect that electricity to the transmission grid. But things are changing. New sources of electricity are being found which are further away. And the further away, the more it costs to connect them. And by their very nature, renewables are just about as far away as you can get.
The current system of transmission charges is based on a methodology that makes some kind of sense, in that the further you are away from the source that's doing the generation, the more electricity you lose along the way. So the transmission charges aren't arbitrary, but one would have to say that this results in transmission charges for linkage to places in the far north, and for example the islands of Scotland, which are very high indeed. Would that be a disincentive to integrating those into the grid? Yes.
This is a thorny issue in Scotland which angers Scottish companies and government ministers alike. The Scottish Energy Minister is Jim Mather.
I think we need to have a genuinely level playing field. I mean, we're talking about a kilowatt of energy in the north of Scotland paying £22, but we have locational transmission charges, and equivalent energy developed in central London getting a subsidy of £6. I mean, that's just outrageous and unhelpful when the renewable energy is there and the UK and the rest of Europe has climate change and renewable targets that they seek to meet. So we're really keen to see the UK government listen more closely to Europe, which is essentially suggesting now's the time to have an absolutely level playing field. And that level playing field will accelerate at this crucial time this fantastic industry for Scotland and benefit everyone, benefit Scotland, benefit the UK, benefit Europe. So we will continue to press to have a much fairer regime that allows us to get real momentum behind this and not put inhibitors and penalties in the way.
So the charges are penalising renewable companies. The danger is this could be stopping Scotland from making money.
A lot of people worry that the current charging regime works against renewables. There is no evidence that it does. There's a very long queue of generators wanting to connect in Scotland. 10 gigawatts of wind generators want to connect in Scotland, in spite of the current charging regime. The only two independent studies that we're aware of that looked into this were commissioned by the government, and they both concluded that profits for wind farms in remote locations in Scotland were actually very high and higher than the profits you could earn in England and Wales, despite the charging regime. So there's no evidence that the charging regime is impeding the connection of generators in Scotland. And if it was, we would ask National Grid to look at the regime again and check that it was still fit for purpose.
Critics say the charging regime promotes electricity generation from fossil fuels rather than low-carbon sources.
I think the system till now has been very much about making sure that generation was close to where it was consumed in order to keep costs down. Because of climate change, because of the imperative of cutting our CO2 emissions, we now need to move to a completely new paradigm, a completely new concept in terms of how we generate electricity, how we transport electricity and how we consume electricity. Now, the best sites for renewable electricity happen to be in remote, rural, peripheral areas such as the northwest of Scotland, the islands of Scotland. And what we need is a charging regime that actually encourages investment there rather than acts as a disincentive to invest there. But at the moment, the system is actually subsidising pollution, is subsidising thermal generation from dirty sources as opposed to encouraging clean, renewable energy in and around Scotland.
Claims that the charging regime discriminates against renewable generation are now gaining attention in Europe. The UK government has been asked to clarify whether in fact it acts as a tax on geography.
Well, it's a complex issue, and Ofgem have got a consultation on at the moment, and I think it's best to wait to see the outcome of it. What we want is a fair system, and clearly in relation to transmission, it's important that the consumers, who at the end of the day have to pay their bills, do get value for money. But I think it's best to wait to see the outcome of this work.
Scotland could be a major exporter of electricity in the future, selling power to England and further afield, and companies would make a lot of money from that. But at the moment, the network between Scotland and England is a major constraint. There's already a bottleneck, and new capacity in Scotland puts further stress on the system. Improving this link and building new ones to continental Europe would be critical for selling our electricity to others.
The term I find quite exciting is the notion of rewiring Britain. And if we can take that beyond our shores, it's really about rewiring Europe and the world. And that for me will most certainly take account of subsea grids. It will be about an interconnected Europe. It will be about Scotland potentially acting as a hub in this part of Europe, connecting Scandinavia, Western Europe, through to Ireland and potentially beyond, and making sure that our renewable potential is not capped by having a limited transmission capacity, but in fact we can generate, transmit and indeed trade on the energy that we produce as a result.
So it's all about pylons. We need enough of these around the country to carry our electricity. If the Scottish and UK governments are serious about renewable energy, they'll have to deal with the grid first.
Collectively, we have to ensure that we have a grid that is fit for purpose. It does meet the needs of the way we're going in energy. It does deal with renewables in an effective way. But ultimately, it is responsibility of government, and I fully accept that responsibility.
If we can fix the grid, we could use our biggest potential source of electricity, the wind off our coast. Offshore wind could meet almost half our electricity needs and could create a lot of jobs and wealth.
I think we missed an opportunity on onshore wind in terms of having manufacturing jobs in Scotland. The big prizes for us are in future technologies such as offshore wind, wave and tidal energy.
We already know how to build large oil and gas platforms, and this gives us a big advantage in offshore renewables.
We have Europe's biggest oil and gas hub in the northeast around Aberdeen, and I think there's now an opportunity to do the translation of offshore technologies that have been developed over the past 20 or 30 years that was built around oil and gas industry, and now translate that into the offshore renewable side of things.
We need more companies building these huge structures and putting them in the sea. In a few years, half the offshore turbines in Europe are likely to be in UK waters, including around Scotland. If we don't build an offshore industry, we'll still be shipping the turbines from Germany.
I'm very much aware of the work that's been done to make sure that these fantastic skills that are based in and around Aberdeen are used to their fullest effect. One of the biggest examples is what's called the subsea sector. And, you know, those people who work there are renowned throughout the world. And of course, their experience in dealing with oil and gas is highly relevant to dealing with offshore wind technology, to deal with wave and tidal technology. And so I think it's a fantastic opportunity for Scotland to enhance its role, to use these skilled people and to develop new skills in the future.
We could make a lot of money from offshore wind. This could be a multi-billion-pound industry for Scotland.
I think what's really interesting at the moment is the way, if you look at the oil and gas services sector in Aberdeen, for example, people have been talking for a long time about how Scotland can transport the skills we have in oil and gas engineering and offshore engineering into the renewable sector, and finally that's happening.
There's another game to play for: water power. This could be worth billions of pounds in exports. If we can harness our water resources, Scotland could make lots of loot. Our expertise in wave and tidal power is centred in Stromness in Orkney, home to the European Marine Energy Centre, or EMEC. Funded by money from Europe, the centre provides somewhere to test new water devices. Rolling on the waves is Oyster, the world's largest hydroelectric wave energy converter. This large cylinder rolls back and forth on the waves, pumping high-pressure water to an onshore turbine. It's ahead of the game, the first device of its kind to be producing electricity. A big achievement for Edinburgh-based Aquamarine Power, whose chief executive is Martin McAdam.
There's no question that Scotland and the UK in general actually leads the world in terms of what's happening in the marine energy sector. And EMEC here is a fantastic facility. Without EMEC we wouldn't be here today. And it's very important, if we're going to capitalise on this new industry, that we have facilities such as EMEC where people like ourselves can come and test our equipment and help get it to that commercial stage.
It's a very expensive process, and the Scottish Government is backing technology like this. But other countries are trying hard to catch up.
Would you say that the race is on to develop this type of technology for Scotland and to make it commercially viable?
Yeah, I mean, there are, as I said, we have leadership at the moment, but there are other countries such as Australia and Portugal and the United States. They're all interested in capturing the energy from the seas. So it's very important that we continue to develop this and we continue to have the great government support that we've had so far. Because if we don't do it, there's no question but other countries in the world will overtake it.
What's happening in Orkney is new and exciting, but can we make money from this and build a new industry? Aquamarine has already created 40 jobs and spent £1 million in the local economy getting to this stage. If they can do it on a commercial scale, they could power thousands of homes and create even more jobs and income. But it's a big if. These are still early days. Neil Kermode, Managing Director of the Marine Energy Centre, believes Scotland is at a crucial stage.
I think getting machines in the water is the first job. We've got to get kit in and find out how well it works, how long it works for, and therefore we'll better understand the costs and the maintenance and all those things. That's critical. To get an industrial sized industry going, we're going to need to make sure we've got grid, somewhere to export the energy. And there are a whole number of softer things which then come around that. We need the skills, we're going to need the training, we're going to need the vessels and all those things, but I think they will come. The key task has really got to be getting metal in the water and learning how to do this.
If we don't, we'll lose our lead just as we did in the past. Remember Salter's Ducks, a pioneering wave generation project from the 1970s, described here on Tomorrow's World by its inventor, Stephen Salter.
That's the first model that I ever made, and it's an up and downer. And this little gadget here was what you need to couple it up to a thing with magnets and moving coils to make it do some work for you, and you can measure the work that it does. So I measured the waves coming in, I measured the amount of push I could get out of it into my dynamometer, and I did my calculation on how efficient it was, and it was about 15%, right, for an up and downer. And I thought that wasn't very good. I would have liked to have got something that did about 25. So then I found that if I tipped it like that, right, so that this back part was deeper in the water, it didn't let so much of the water get past, so much of the wave get past. And I could get about 50% out, which is very good.
Salter's ducks were ahead of their time and they seemed to work, but they never made it into the sea. More recently, the Palamas wave device was developed in Scotland, but was then lost to Portugal, where there was more government support. All very similar to what happened with wind 20 years ago.
I honestly think the politicians have woken up this time to not making the same mistakes we made with wind in the past. We had here in Orkney some major wind turbines in the 70s and 80s, but we let our lead go, and there is a risk we could do the same thing with marine. The Danes, on the other hand, stayed with wind. They kept plugging away at it, and they put in £130 million every year for 10 years. That's 1.3 billion. But their sales last year were £10 billion. So that kind of investment has paid back, and that's exactly what we need to do this time. We mustn't let this lead go. It would be criminal to do so.
There's an amazing resource beyond our shores, and there's still time to make a lot of money from it. A chance to build a new industry from the seas, which the Scottish Government thinks could support 12,000 jobs.
You've got 25% of offshore wind and 25% of the tidal resources of Europe, then it's an enormous resource, and that is going to be a very big focus, a very big industry. Engineering companies combined with ports, combined with academia, combined with North Sea oil and gas companies could help to accelerate this industry forward.
Now, I know this programme is about renewable energy, but there's something else Scotland could make a lot of money from in the future. It isn't remotely renewable, but we do have it in abundance. It's coal.
Most people I've spoken to believe that coal will continue to be part of our energy mix for some time. Wind power is unpredictable, so we'll need other sources like coal as a backup. But we can't just keep burning it the way we do at the moment, because coal-fired power stations are a major source of CO2 emissions. So companies will have to find ways of capturing those emissions before they're released into the atmosphere.
Longannet Power Station on the banks of the Forth generates enough electricity to power up to a quarter of the homes in Scotland, but it also produces a tenth of our CO2 emissions. We'll still need coal plants like this, but we'll need to reduce their carbon. Capturing and storing it, a scientific process known as CCS, could remove carbon dioxide from the flue gases of power stations. A CCS experiment is underway here, and I was shown around that experiment by project manager Stephen Adamson.
Right. So this is where it all starts. This is a feed from the power station's exhaust gas. The gas comes in that big pipe there, which has got carbon dioxide in it. It's being pre-treated, and then it goes into the unit behind us where the real magic happens. It will be a massive technical challenge, a massive undertaking, but we believe we've got a world-breaking consortium between ourselves, Grid and Shell, and we're very confident about the results we can deliver.
It looks like something from a science fiction film, and in a way it is, because this technology has still to be proven on a full-scale plant. Of course, despite its low carbon potential, some people would say there's no such thing as clean coal.
Fundamentally, CCS is about allowing us to prolong the life of fossil fuel power stations. So for Longannet, CCS is essentially a lifeline into the future. We have long-term plans for Longannet. CCS has to be part of that.
This is part of a UK government competition to try to get CCS to a commercial scale, or 300 times bigger than this experiment. Scottish Power is one of two companies working towards a £1 billion government prize, which would help them crack this technology and make them rich.
One of the reasons that we are so keen on developing our retrofit solution for the UK competition is that we will have a product which can be applied to every fossil fuel power station worldwide now. Because none of those stations have been built with carbon capture and storage in mind. Therefore, we can give a solution which we can effectively slip into their operating regime without fundamentally interrupting or disrupting the operation of the station.
The challenge will be making it cost effective. The The process uses a lot of energy, about a quarter more than a conventional coal plant, to produce the same amount of electricity.
It is energy intensive, but what would be the price of not doing it? We fundamentally believe that CCS is something that has to be addressed. We are very actively involved in it, both here and with our consortium partners for the UK competition. Clearly, the energy question is the question that we want to crack, and we are very, very aggressively tackling that.
We're still several years away from having CCS running on a full-scale plant, and despite its enormous environmental and economic importance, the UK government is only sponsoring one large-scale competition. Stuart Hazeldine is Professor of Carbon Capture Technology at Edinburgh University.
I think personally that given the size of the difficulty of capturing carbon dioxide, the government's being far too timid and cautious on this, because running one competition will be very good at developing one power plant, but what we really need to be doing is developing a whole industry here, because it's quite clear from the Committee for Climate Change recommendations that we need to have fitted carbon capture and storage to all our power stations in the UK by 2030. Therefore we need multiple demonstrations to be happening now.
Okay, so this is the apparatus then?
This is it, and this is what we can try and demonstrate carbon dioxide storage with.
Storing the captured CO2 is another potential money spinner for the UK.
Deep underground, because
we can pipe it to the North Sea and store it in porous rocks miles below the seabed. The very rocks we've been taking oil and gas from for 30 years.
Let's feel that solid rock.
Professor Hazeldine showed me how it works.
Imagine this pack of cards to being the layers of rock in the North Sea. What we're trying to do is fill one of those layers of rock full of carbon dioxide, so we're at least 1 kilometre, maybe 2 kilometres below ground. So it's a very thin, widespread layer deep below ground. And here's the surface where the seabed of the ocean might be. And then the piece we're interested in is this pairing of this porous layer of rock, and these balls in here are representing the individual grains of sand in that layer. And you can see there's lots of spaces between those balls, which are the pore spaces, which is where the water or the oil or gas, or in future the carbon dioxide, will be. And on top of that rock, which is porous and can hold the water, we've got this impermeable layer, this red layer of plasticine in this case, but the point is, just like real rock underground, that stops the flow of water or the flow of gas coming up. And with carbon capture and storage, what we're trying to do is choose a position to drill a borehole into that, like this tube here represents a borehole. Drilling a borehole slightly off to the side so we don't puncture the hole in the top, and then injecting carbon dioxide from a pipeline network. And as we watch, if I blow into this with my carbon dioxide, then this water level will move down. What we've done there is inject extra gas down into the rock, and you can see the original water levels move down. If this was an oil field though, that could be oil, and by injecting the carbon dioxide we can bring extra oil up to the surface, because half of the oil is still underground in the North Sea. And so we can balance the carbon going in and the carbon going out and have a very low carbon source of extra oil for the UK.
So actually pumping in the CO2 could help us get these last critical billions of barrels of oil out of the North Sea, and that's another huge prize. And not only an income for Scotland in terms of capturing our own CO2 and in terms of carbon trading, but also the potential to capture CO2 for Europe. And we're talking here about cavernous spaces, huge capacity, 200 plus years of capacity out there.
So there'd be a market for carbon, and other countries would pay Britain to take it off their hands and store it. This could make the North Sea a money spinner for years to come, if it works.
If we imagined the UK taking carbon dioxide from the closest European countries like Denmark, Netherlands, Germany, Poland, Belgium, then we could easily imagine 500 million tonnes a year of carbon dioxide from the mainly coal-fired power stations in those regions piped into the North Sea, stored in pore space offshore of the UK or offshore of Norway, and if we charge €10 per tonne for that, then we could gain £5 billion a year.
The UK government and all of us would enjoy another North Sea tax bonanza, just like the money which came from oil and gas. But hold on a minute.
I was walking down the street in the town where I was born. I was moving to a beat that I never felt before.
We're still years away from getting carbon capture up and running, and others are in the race to get it working. I travelled to Columbus, Ohio, to the headquarters of American Electric Power. They're already capturing carbon, same as back home. The difference is they're storing it too. I met the company's president, Michael Morris.
Coal is 50% of the base load generation in this country. It has been for a long, long time, and I expect it will be for a long time to come. To American Electric Power and our customers, coal is essential. We serve the manufacturing heartland of this country, from Michigan in the north to Texas in the south, Virginia in the east to Oklahoma in the west. It's a great deal of where the manufacturing base is, and we think coal is essential to us, to our customers, to this country, and really, quite honestly, to the world.
The US government clearly thinks so. The Obama administration has just given AEP $300 million to help build a commercial-scale carbon capture plant.
This is a worldwide challenge, and it's difficult to say that the customers that we serve out of the Mountaineer Station in these 7 states in the upper Midwest ought to fund the entirety of bringing that technology forward. So I do think there's an opportunity here for the government to involve itself. I'm not a big fan of government subsidies and government intervention, but this is a game-changing technology, and I think that they ought to step up and do just that.
Yeah, the revolution starts now.
This is where the revolution is happening. The Mountaineer plant in West Virginia is the world's largest single-burner coal-fired power station. And this is the plant's carbon capture experiment, 20 times the size of the one at Longannet. Brian Sherrick, who's in charge of the project, told me why this experiment is at the cutting edge.
We're as far as we know, the first integrated CO2 capture and storage project in the world on a coal-fired power plant. There are several facilities where they have small pilot capture facilities. There's actually commercially available CO2 capture technologies or processes that are running. But as far as on a coal-fired power plant, we're the first to do it, integrated CCS. As far as we're concerned, our next commercial scale project we plan on having online by 2015. So by 2020, you should be able to retrofit that technology on several power plants.
What you do to stand in the land, just follow your heart, your revolution starts now.
Here in West Virginia, they're talking about capturing the carbon dioxide from this power plant and storing it under the ground here in maybe 5 or 6 years' time. Now, that's not long at all. But in other countries like Germany, Canada, this technology is moving quickly as well. So if Scotland wants to take a lead, then I think we need to move faster.
The revolution starts now.
Far from here, back in Britain, politicians insist they understand the urgency.
It's a huge international race, and I agree we need to be at the front of that race and in the front of that race. I mean, equally, there's huge developments going on in Japan just now. They're pressing ahead in a whole range of carbon capture demonstrator and scalable plants, and working in collaboration with the Australians and others. And here too, we've got, I think, again, the attention of many of these other countries, and we've got stars here in Scotland. This is us not trying to invent new technologies. This is us scaling technologies and happening across the world because the world's aware, and the world's aware that there's huge markets for this, same as for the renewables.
Well, I'm very much aware that we're in a race, that there is huge potential if we're one of the winners. We are, in the leadership pack, and the proposals we've made for up to 4 scaled up projects. We've announced very recently the funding mechanism as to how we're going to support CCS. Look, I'm confident we've got the people, we've got the companies, we've got the technology to really make something of this. And it's important not just for the United Kingdom in terms of how we deal with our own coal production, but it's important in terms of exporting skills and technology throughout the world.
Whether we're looking at renewable generation or the future of coal, we're at a turning point.
Electricity is a pretty important commodity. It lights our homes, it runs our factories, and it drives our economy. Now the government, and indeed widespread public opinion, is challenging the power companies to find greener ways of producing electricity. This is a big challenge because so much of the technology is still experimental. For now, Scotland's holding its own, but we need to move way beyond this stage if we're to reap the economic benefits of renewables.
And hereby declaring the world's largest operating hydroelectric wave generating device connected to the grid.
Because even as exciting new green technologies come online, we need to do more if we want to make money. And Britain's governments are going to have to stump up much more cash before we see any benefit.
Will it happen spontaneously? I don't believe so, and people understand this. The private sector are going to have to be persuaded, for example, to get involved with carbon capture and storage. They're going to have to be persuaded that it's financially viable to invest in marine renewables. Now, I think they are up to a point, but I think additional incentives will still be required to persuade them finally to meet the gap. I don't think the private sector will find it difficult to meet all of the gap. I think there will have to be some public, and this is recognised, there will have to be some public sector support in the early stages at least.
We've seen the potential Scotland has in renewable and sustainable energies, but there are many obstacles to making money from them. Offshore wind is very expensive and will need greater incentives. Despite our potential in marine energy, the whole sector remains underdeveloped. Carbon capture is both expensive and in its infancy. And then there's rebuilding the grid. I have to admit to wondering if we can really pull this off. The will seems to be there, but there's a lot of uncertainty.
Will the industry get the grid connections they need to transport the power they generate to where it's going to be consumed? Will they support the industry through various rounds of funding to bring new technologies to market? Will they invest in the skills that the industry needs? And will they maintain a regulatory system that allows renewable energy to be competitive?
While making this programme, I kept hearing and reading about renewables bringing a second energy boom. People kept drawing parallels with our North Sea oil and gas industry. I found an accountant who'd looked at this claim. He's sceptical.
The analogy is a strong one, but I don't think people should expect to see economic development on the scale of North Sea oil. It's just not the same scale and pace of development. But on the other hand, when we get our renewable resources right, they will be there for the very, very long term when oil reserves are substantially exhausted. I mean, it will be a multi-billion-pound industry in terms of the amounts invested. In terms of the impact on local economies, it will be significant. It will create local jobs, but I think we're looking at something far short of an equivalent to a second oil boom in terms of economic impact.
But let's not be too downhearted. We have a real opportunity to make money.
And the world is made of energy, and the world is electricity.
Once we get the critical mass, the opportunity for Scotland, I think, would be a major one. Carbon capture and storage, offshore wind, marine, network technologies, and other relevant technologies translating know-how from oil and gas. This is a real game to play for. The opportunity is here, and I think the job opportunities and the wealth creation and the industrial base that could be created could make us absolutely amongst the leaders globally.
It's gonna be alright. It's gonna be alright. Yeah.
The resource is definitely there. The appetite is there for it. We have the regime in the background and the enthusiasm. You know, we have a number of renewable energy developers based in and around Scotland, and I think that the partnerships that are happening at the moment are certainly putting us in the best position.
These companies know their work is good for the planet, but let's be honest, they're in it to make money.
At the end of the day, we've very strong shareholders who've supported us to get this far, but people invest in this technology not because, you know, they want to save the planet, which is one of the objectives that we have, but it's because that they want to make money out of helping the environment. We have an obligation to our shareholders to develop this commercially and to create a technology which is competitive and then to take it around the world.
We're all paying for this. Our bills are going up and our taxes are funding green technologies. But those in the industry believe it'll be worth it.
We need to all accept that we're going to need to pay more for our energy in the future, whether that's petrol to fill the tanks of our cars, gas to cook or heat our homes, or electricity to power industry. There is no easy answer to the rising cost of energy. A recent report by Ofgem actually suggests that the more renewables we can get into our electricity mix over the next 10 to 20 years will actually deliver the lowest prices for consumers.
And the politicians remain cheerfully optimistic.
I think it's more than a once-in-a-generation opportunity. I think it's a once-in-a-century opportunity. I'm confident that we have all the skills, the enthusiasm, the determination to make sure it happens.
This is us winning the lottery of life again. We won it with oil, we're now winning it with renewables, and there's an absolute obligation on us to capitalise on it. And I think the really exciting thing is there's a chance for Scotland to capitalise on it and be in a world leadership role. And I think in this competitive global economy, if you have a chance to be in a world leadership role, you've really got to grasp that. And we're a very fortunate country.
Renewable energy isn't going to make Scotland rich overnight. It's going to be a long, hard slog to develop the technology and the potential industries that could grow from it. It's a hugely expensive risk, but the rewards could be with us for years to come. We have the resources and we have the expertise, and it would be a shame not to capitalise on that.